Hello students, I am Professor Bharti Kare. Today I am going to start the module 4, that is embedded. Today's topic is quality attributes of. So what is quality attribute of embedded system? The quality attributes are non-functional attributes that need to be documented properly in any system design. If the quality attributes are more concrete and measurable, it is going to give a positive impact on the system development process and the end product. There are various quality attributes which has to be addressed in any embedded system development, but now they has been broadly classified into two categories: operational quality attributes and the non-operational quality. The operational quality attributes are those attributes which are relevant quality attributes related to the embedded system when it is in the operational mode or the online mode. These are those attributes which will be measured when the system is online or in the operational mode. Non-operational quality attributes are those which will be addressed for the product which is not on the basis of operational aspect. Where operational quality attributes, it is consist of response, throughput, reliability, maintainability, security, safety. And non-operational quality attributes: testability, debuggability, availability, portability, time to prototype and market, per unit time, and the to see the operational qualities in detail. The first one is the response. The response is the measure of how quickness of the system, how fast your system is going to respond for the input variables. Most of the embedded system, they will demand for the fast response, which should be almost real time. For example, if you are going to see the flight control application or a, um, a automatic brakes in the cars, so they should represent the real-time manner. Any response delay in that system which are going to create a potential damage to the safety of the flight or the car as well as the passengers. And it is not necessary that all the embedded system should be in the real time in response. For example, the response time requirement for any electronic toy, it's not at all time critical. There is no specific deadline that this system should respond within. The next is throughput. Throughput is the efficiency of the system. Here, throughput will be defined as the rate of production or the operation of the defined process over the stated period of time. How much product or how much it is going to operate over a period of time, that will be the throughput here. The rate, it can be expressed in terms of unit of products, batches produced, or the any other meaningful measurements. For example, if you are going to take the card reader, here the throughput means how many transactions that card reader can perform in a minute or in an hour or in a day. That will be the throughput of that card reader. Then throughput is generally measured in terms of benchmark. A benchmark is a reference point by which the something can be measured here. Even the benchmark can be used to set up the performance criteria that the product is expected to meet, or standard product that can be used for computing the or sorry comparing the other products of the same. The next is reliability. Reliability is the measure of how much of percentage you are going to rely upon the proper functioning of the system, or what is the percentage susceptibility of the system to be failure. Here it is going to use the two terms: mean time between the failure and mean time to repair. Here, mean time between the failure is, it is a frequency, how many times the failure is happen in a hour, in a week, or the month. Whereas the mean time to repair is how long the system is allowed to be out of order following the failure. For an embedded system with the critical application need, it should be of the out of order. The next is maintainability. It is going to deal with support and maintenance of the end user or the client in case of technical issues or the product failure, or on the basis of the routine system checkup. Here, maintainability, you can say that servicing the system. Maintainability and reliability are considered as the two complementary disciplines. A more reliable system, you can say the system which is going to work properly, that system will be less corrective maintainability requirement, and you can say as the reliability of the system is going to increase, the chances of failure and the non-functioning will be reduced thereby. Why? The need for the maintainability is also reduced. Maintainability is closely related to the system availability. Maintainability is classified into two categories: scheduled or the periodic maintenance, even it is called as the preventive maintenance, and the maintenance to the unexpected failures or correction. Most of the embedded product it will be implemented by making use of consumable components or many certain components which are subjected to wear and tear, and there should be a replacement on a periodic basis. So the period may be based on the total hours of the system usage or the total output the system um, delivery. For example, if you are going to say take any camera, so it is going to work on the batteries there. So on a period basis you have to recharge that period, you have to recharge that battery, as well as after some years you have to replace that battery also. With an example we are going to see how the maintainability will be done here. If you are going to take a inkjet printer, it is going to make use of the ink cartridge. So this ink cartridge it has to be replaced after each n number of printouts has been taken. So this is the example of scheduled or the periodic maintenance. Here every time when we have taken some certain number of printouts, the ink cartridge will be get replaced. Okay, then the next part of our printer will be the paper feeding part. If that part will be fails, then it requires the immediate repair or replacement to rectify that problem. So this is an example for the maintenance to the unexpected. Then in both of these maintenance, that is your scheduled and the repair, the printer needs to be brought offline, and during this time it will be not available for the user. So in any embedded system design, the ideal value of for availability is expressed as AI, where AI is the availability in the ideal condition. It is equal to mean time between the failures divided by mean time between the failures plus mean time to repair. Then the next attribute is your security. Security aspect, it is going to cover the confidentiality, integrity and the availability. Confidentiality means the protection of data or the application from the unauthorized disclosure or the users. Integrity deals with protection of data and the application from the unauthorized modification. Availability, protection of data and the application from the unauthorized access the users. The example is we are going to see the personal. So the personal assistant PDM, it is a shared one. There should be some mechanism in the form of username and the password to access into a particular person's profile. It's an example of availability. Also, all data and application present in the PDA need not to be accessible to all the users. Some of them are specifically accessible to the administrators only. So administrator and user level of security should be distinguished here. So this is the example of confidentiality. Some data represented in the PDA may be visible to all users, but there will be some restrictions there. No necessary permission to alter the data by the user. So here no modification will be done. This is an example. Next is safety. Here security and safety are confusing word, but safety deals with the possible damages, physical damages of the system which can happen due to the operator, public and the environment, or it may be due to the breakdown of the embedded system, the emission of the radioactivity within a system or the hazardous materials from the embedded. The breakdown of an embedded system may occur due to the hardware failure or the firmware failure. So safety analysis, it is a must in product engineering to evaluate the anticipated damage and determine the best course of action to bring down the consequences of the damages to an acceptable level. Some of the safety threats are sudden, like product breakdown. Some of them are gradual, like hazardous emission from the product. Thank you.